How you doing, Tony? This is Beach Bums, and we chose to do the egg drop problem since we love you so much. We're on the roof of a physics building, and it's 46 meters above the ground. You, who is 1.8 meters tall, is walking along the side of the building at a constant speed of 1.2 meters per second. If we wish to drop an egg on your head, where should you be when we release the egg, assuming that the egg encounters no appreciable air drag? So I'm going to draw what we know and what the problem gives us. So here goes the one pen. Now here's you, and you are 1.8 meters tall, and you're walking at a constant velocity of 1.2 meters per second. We are up here, the A, and we know the building is 46 meters, and we also know that G is -9 meters per second. Alright, and Christina here is going to start us off.
Alright, well, we know we have to use one of the motion equations, and the one that we're going to have to use, this is how it's formally written out, and we'll have to convert x final equals x initial plus, velocity, initial velocity times time plus 1/2 acceleration times c squared. Now, this would be if you're dealing in the x-axis. We're actually dealing in the y-axis, so we're going to have to change it a little bit. So y final is equal to, well, this would be 0 because y initial would be 0. So that cancels out. So the initial velocity times t plus 1/2 a t squared. We can actually simplify this even more because the initial velocity is 0. So t times 0 is obviously 0. So once again, we're trying to find t so that way we can solve for the x later on, which equals 1/2 g, which is the same as a t squared. And then second, plug in the numbers and figure out where it's coming.
So y final is 4.6, right? 4.6 minus 1.8. 46 meters. 46 meters minus 1.8 meters equals 1/2. G is -9.8 and t squared. So we solve this with a calculator. Those things. Wow. So it's 46 minus 46 minus. And then calculator's not going to work in. So it's 44.2. I can't do math in my head. Yeah. Half of -9.8. 9.8. 4.9. Negative t squared. 5 by -4.9. Cancel, so 44.2 divided by 4.9 equals -9.02 t squared. Take the square root of that. How did you do that on this calculator? I don't know.
Should just be 3 seconds.
3, yeah.
Because of 9.
Yeah, so that's right.
Yeah.
So it's about 3 seconds for the egg to drop.
So that's the time?
So that's the time it takes to get from here to here for the egg.
So now we use
what?
now we use the velocity equals d over t to find
the distance. Yeah, we just need to find x initial and x final.
No, I don't think we need to find x initial. We just need to find x final about where he's going to be away from the building. So that's what we're looking for. It's x final right there.
So how do we find it?
Oh, he said we can use v equals
d over t.
Equation.
So we're finding D, right? So it's D equals it's D. Right. So we know the time is 3 seconds. So what's V?
V is
V is
1.2 meters
1.2 meters.
per second.
Can somebody solve it?
So
Here, Melissa.
times 3.
3.6.
Meters per second.
So, our professor needs to be 3.6 meters away from the building in order for us to hit him with the egg.
Knock on the head.
Yeah,
Hit him in the head.
in 3 seconds. So,
That's about all I'm asking for, right?
excellent.
Okay. So we got it.
There you go, Tony.
Yay.
There you go.
15 beach balls.
Yay. Good job, team.
Good job, team.